Hola, la clase. Today we are going to cover section 3.8. Use inverse matrices to solve linear systems. Inverse matrices, kind of like inverses in the previous chapters we dealt with. Let me give you an example. Section 3.8. 2/3 x equals 4. You don't have to write this down, but just think about this for a moment. How would you solve for x? How would you get x by itself? You would multiply both sides by what we say is the inverse of 2/3, which is 3/2. So if I multiply by the inverse of this, I get this whole side to be 1x, right? So I'd multiply this side by 3/2. So the idea here is get rid of, if I want to solve for x, I need to get rid of 2/3 by multiplying by the inverse of 2/3. Okay, now x equals, in this case, 12/2, which is 6. Same idea for matrices. So in this problem to my right, if I want to get x by itself, big X means matrix x. If it was a little x, it would mean a scalar, but it's a capital X. If I wanted to get x by itself, I would have to find the inverse of this matrix right here. Same thing as over here. I want to get x by itself. I need to get rid of 2/3 by multiplying by the inverse of 2/3. Same thing here. I want to get rid of this matrix by multiplying by the inverse of this matrix. So now we need to know, how do you find the inverse of this matrix? So for any 2 by 2 matrix, here's how you find the inverse of the matrix. So if matrix A is equal to these 4 elements, 2 by 2, then A inverse, if you don't know this, anytime you see something to the -1, A to the -1, that's the inverse of A. Okay? So there's A, there's the inverse of A, is equal to, here's how you find it. Know this formula. 1 divided by, looks like absolute value, but it's not. See that right there? Notice those symbols. Looks like the absolute value of A, but that means, hopefully you remember from the last section, that means the determinant of A. So back here, here's A, so find the determinant of A. Times, so take that times something else. This right here is a scalar, whatever that number comes out to be, 1 over whatever the determinant is, times, and all you have to do is figure out this pattern. Basically the pattern is switch A and D of the other one, D, A. So this one was AD, this is now DA, and then all you have to do is make the other two opposites. So opposite of B, opposite of C. Remember this pattern right here. Okay, understand it. Now I'm going to break it down a little bit better than that, just one step. So the inverse of whatever this matrix is equal to 1 over, instead of writing it like this, the determinant of A, well, you know what the determinant of A is, AD minus BC. So I'm just going to write AD minus BC times the same thing we wrote up there. Switch D and A, and then opposite of C, opposite of B. Okay? So you can think of it this way or think of it this way, same thing. So let's go find one. Let's do one. So let's get another page here. Let's do an example. Example number 1. So if A equals 3, 8, 2, 5. That's a 5. Find this, which means the inverse of A. So basically, right now, I'm saying, okay, here's 2/3. This is like represents 2/3. Find the inverse of 2/3. Well, you know what that is, but so let's do it within a matrix. Here we go. So the inverse of A is equal to 1 over the determinant of A. So we can write it like this. The determinant of, let's put it inside, 3, 8, 2, 5, times, that's just going to be some scalar number, times, let's switch them up, remember? D and A switch. So 5 goes here, 3 goes down here. Then the opposite, negative 8, negative 2. All we have to do now is basically simplify. So equals 1 over, now what's the determinant of this matrix? Well, downward is 15 minus upward 16 times this right here, 5, negative 8, negative 2, 3. Once again, let's multiply this scalar right here times this matrix. Well, that scalar is 1 divided by negative 1, which is just negative 1 times that matrix right there. So in the end, it's basically negative 1, that's negative 1 times the matrix, which equals negative 1 times 5, negative 5, positive 8, positive 2, negative 3, just multiplied by negative 1. This right here is the inverse of A. Alright, I want you guys to take a moment to practice finding inverses of a 2 by 2 matrix. Go ahead and pause the video and find the inverse of this one right here. Here's your answer. Let's do a second one. Find the inverse of this matrix. Pause the video. Here's your answer to number 2. Alright, so let's use the concept of inverse matrices to solve a matrix equation. Up here, previously we saw that this matrix, we'll call this matrix A, we'll call this matrix X, and we'll say this is equal to matrix, we'll call this one right here B. So we have this equation, A times X equals B, in short. Now what we want to do is we want to get X by itself, right? So to get rid of matrix A, we have to multiply by the inverse of A. So we take that, we multiply over here. A inverse times A will give us something right here. Equals X. So X is left over, equals. Now what we have to do here, be careful with this. Take matrix A and multiply it right here. It has to be first. Now I want to make a little note of that. A inverse times B. When you take A inverse times A, you get something that we call the identity matrix. The identity matrix is like the number 1. So here's the identity matrix. Circle that. Know that term. X equals basically the inverse of A times B. So all you have to do is figure this part out right here, and we're finished. So first thing we have to do is we have to find the inverse of A. Well, here's A up here. So let's go find the inverse of it. A inverse is equal to 1 over the determinant of A, the determinant of 2, negative 7. It's not working very well. Negative 1, 4. To find that determinant. Okay, times the matrix. Let's flip-flop these. 4 goes up here, 2 goes down here. Then make this negative 1, positive 1. Make negative 7, positive 7. Let's multiply. First, let's find the determinant. 1 over, let's see, AD is 8 minus 7 equals 1. This does not always happen, but that's okay. 1 times this matrix, 4, 7, 1, 2, obviously is the same matrix. So the inverse of A is equal to 4, 7, 4, 1, 7, 2. Okay, so right now I want you guys to go back and see the similarities between the matrix equation over here And let me write a new equation over here. 3/4 x equals 6. Now look at the parallels. You got a x equals b, and you got, this is like a x equals b over here. Very similar. So now what I'm going to do is, how do I get x by itself? I multiply by the reciprocal of a. If this is a, then this is the inverse of a. If these were matrices. So over here I'm going to do the same thing. I'm going to multiply by the inverse of a, only do it out front. So multiply by 4/3 over here. So basically multiply a inverse on both sides of the equation. Look what's left over. When you multiply an inverses together, in a normal algebraic problem you get 1, and then you get x equals, in this case this would be 8, your answer. Notice the 1 beforehand. The 1 is just like the identity matrix. That's just like the number 1. When you multiply an identity matrix times anything, you get that other matrix. It keeps its identity. Okay? Let's go back to this problem right here. Let's find the second part. So basically we have x equals a inverse times b. So a inverse was 4, 7, 1, 2 times b was -21. Oh goodness, here we go. -21, 3, 12, -2. Multiply these two matrices together and you have x. So multiply these rows times these columns and get your answer. Okay? The answer for x is 0, -2, 3, -1. Now let's try some problems on your own. Try this example right here. Pause the video and then we'll check your answer. The answer is -1, -2, 4, 1. Let's move on to the next. Alright, the next type of example, example number 3, we're going to use the calculator for. So I'm sure you're happy about that. What I want you to do is put matrix A into your calculator. Okay? So go hit the matrix key on your calculator. I'll go to my calculator here. Go to your matrix key. It's not the same key as mine. Yours is over here above the x and -1 key. Okay? And you'll be here. So go over to edit, and you can edit letter A, and then 3×3, and then type all your values into the matrix here. Pause the video and do that. Alright, now that you've done that, you want to quit, and you want to find the inverse of A. Well, the inverse of A, I showed you, is, if we go back to matrix, go under names, hit A. That's just regular matrix A. If I want the inverse, I told you x to the -1. So A to the -1 power means the inverse of A. All you have to do is hit enter, and there you go. Matrix, the inverse of A. Now, how do I know that's the inverse? Well, remember in regular numbers, regular algebra, if you multiply 2/3 times its inverse, 3/2, you get 1, right? Well, the same thing for matrices. If I multiply a matrix, watch this, if I multiply matrix A and times it by its inverse, which is, go back to matrix, type in A again, to the -1 power, notice matrix A times the inverse of A. Well, if we were talking about normal numbers, the answer should be 1. But since we're not talking about normal numbers, we're talking about matrices, here is your final answer. 1, 0, 0, 0, 1, 0, 0, 0, 1. This right here is called the identity matrix. Now this is a 3×3. Do you remember the 2×2, where it was just these two? This diagonal is always full of 1s, and the rest should be 0s. So a 4×4 identity matrix should have 1s in the diagonal right here, and everywhere else should be 0s. Okay? Now notice, let's do this. Let's take that matrix right there and multiply it. So your answer, which is the identity. So what happens when you multiply the identity times something? So the answer times, let's go get a matrix. The only one I filled in was A, so I'll pull it out here. What do you think would happen when I multiply the identity times A? Think about that for a second. Okay, what happens when I multiply 2/3 times 1? You should get the same thing, right? Well, that's what happens here. Look what happens. A was 2, 1, -2, 5, 3, 0, 4, 3, 8. So the inverse, or no, I'm sorry, the identity times a matrix should give you the same exact matrix A. This matrix kept as identity. What if you put A first? Does it matter? Well, normally it does, right? For matrices, order matters. But when you multiply by this guy right here, whether this matrix is first or second, it actually doesn't matter in this case. Okay, so it doesn't matter only for this case right here. Everything else, order of matrices matters. Take a moment to solve this practice problem by finding the inverse of this matrix. Then it says check the result by showing that A times A inverse is equal to this right here is the identity. That I means the identity. Okay? Does A times A -1, the inverse, equal the identity? Okay? That's how you can check if two things are inverses or not. Okay? Because if they multiply together, they have to be the identity in the end. Alright. Go ahead and take a moment, pause the video, find the answer. Your answer should be right here. Alright, last problem in this section that I'm going to do. Actually, I'm skipping the word problem. But the last problem here is solving a linear system, which you know already how to do a few different ways. You can use Cramer's rule to solve this system, which you have to know how to do. You can use elimination, substitution, graphing, all these ways. Here's another way, alright? Step number 1. See these numbers here? These are all the, well, x isn't, but 1 is. 1 is the coefficient. What we're going to do is we're going to make a matrix out of the coefficients. Then we're going to make a matrix out of the variables we used. So here's what we're going to do. Write this system as an equation. Matrix A times matrix X equals matrix B. Now what do A, X, and B stand for? Well, A is the coefficient matrix. So what I want you to do is make a matrix out of those 4 coefficients. You can put it right here. We're going to multiply that by the matrix of the variables. So what variables are we using? We're using X and Y. So we're going to make a matrix out of X and Y. That's it. And lastly, this is going to equal the matrix of the constants. So how many constants do you see? Well, I see 1, 2 constants. So we're going to put 2 elements down here. So watch what happens. Write in the exact order that you see it right here. It has to be in standard form for you to do this very well. Okay, put it in standard form. Make a coefficient matrix. 1, 2, 3, 4 elements. There it is. Okay, get this out of the way. Alright, here's your coefficients. Here's your variables. So notice this is a 2 by 2. This is a 2 by 1. And our answer is a 2 by 1. Okay? So all you have to do now, think about this for a second. What we just did a couple examples ago. We want to solve for this right here. Basically, we want to get this matrix by itself. How do you do that? We want to get rid of this matrix right here. How do I get rid of this matrix right here? Just like a normal problem, multiply by its inverse. So if I take this and multiply by its inverse, basically I get like the number 1, right? The identity matrix. And if I multiply this side by the inverse, I have to multiply this side by the inverse. Okay? So, next, find the inverse of A. Alright, so you should take a moment to do that. Let's go back. You do that. Write it down. Pause the video, find the inverse of A. Okay, you should have this as your inverse. Now pay attention. We had AX equals B. All you have to do, listen to this, X is your variables. That's what we want to know. All we have to do is get rid of A by doing this. Multiply this side by the inverse. And what happens to these two? They kind of cancel out and become like 1. And then you have to multiply the other side. But it has to be in the front. Remember that. By A inverse. Notice what I did. I multiplied both sides of the equation by the inverse of A. When you do that, this cancels out basically. And you're left with your variables equal whatever matrix is over here on this side. Okay? So all you have to do right now, take this A inverse and multiply it on this side of the equation. So let's go back. Here is the right hand side of the equation right here. Take A inverse and multiply it to B. See how we multiplied it to B right here. Take A inverse, multiply it to matrix B, and you should get this matrix right here. Now the book doesn't do a good job of showing you the 1 or 2 steps in between. Okay, so here's the gist of this last example. 1, make a matrix out of the coefficients, make a matrix out of the variables being used, and then make your constant matrix if it's in standard form. Easy, right? Now, the only other thing you have to do, you have to get this by itself. So what I'm going to do right now is multiply by A inverse right here. Do you see why I'm going to do that? Because A inverse times A is the identity matrix 1, 0, 0, 1. Basically that's 1, right? Times your xy, which is up above, equal to whatever's left over here. Now look, since I multiply this side by A inverse, I'm going to multiply this side by A inverse first and put those in there. See A inverse? Put that over here. I don't think I have enough room. 4/11, -1, oh boy, 11ths, 3/11, and 2/11. All I'm going to do is multiply both sides by A inverse. That's it. If you want to keep it that simple, think of it like that. That's all it is. Okay, now these two things kind of cancel out, right? Left with this equal to, now you have to go find the answer to this. Now for time's sake, you can just type this in the calculator. 2 by 2 times a 2 by 1, and you'll get the answer right here. The answer is 5, -3. Now notice what's going on here. This is like 1. You don't even have to look at this. 1 times xy is just xy. So basically you have this. Xy equals this. So what does this tell you? Look, these two matrices are equal. That means x has to be 5 and y has to be -3. Final answer? Ooh, x is 5, comma, y is -3, close parenthesis. There's how you solve a system using inverse matrices. Okay, here's your last problem to do for this section. Use that concept of inverse matrices to solve this system. Take a moment, pause the video, and then you'll see your answer. Answer 3, -2. Alright, when you're finished, just look up and I'll have some other things for us to do for the rest of the period.